Okay, I think we can start now. So, welcome everyone to the live session 2 for week 5. And today we will be continuing our thing, whatever we are doing on the regression part. So, the remaining part which was left was hyperparameter tuning. So, today we will look into it. And yeah, after today's session, I will share the collab notebook link into the meet this Gmeet events, like the previous session, previous week 4. Okay, all right. I think it's visible to you. Okay, we don't need this now. So this is the notebook which we were working on previously. Uh, I think we changed the this sklearn version as well. At the end of the previous session, we changed the sklearn version to something 1.2.2. It was previously something 1.6.1. So yeah, we will first run all the things which were there. So we will be working on, again, we will be working on the California housing data set. And yeah, so these are the three features which we are looking into: the median income, house age, and the population, to predict the housing price, I think. And yeah, so we were keeping the test size as 0.3, that is 30% was kept for the testing purpose, and the 70% was used for the training purpose. We use the polynomial features, this thing, to fit a polynomial curve, and we tried to change the various kind of degrees. We saw the change of this mean square error and the prediction with for different kind of degrees. We started with something 2, and we looked into 3, 4, 5 up to 10 or 20. And we also looked into, beside linear regression, we also looked into this SGD part, that was in the other notebook. And as you can see, it's like pretty much correlated, right? This is coming like a straight line. It means that this is the predicted value, this is the y-axis, and this is the actual value. So these values are coming as if like a straight line, which means with an starting from the origin, it means that the prediction is quite accurate as with the actual values. Okay, this I have commented out because we were seeing for different kind of test features. We were picking a different number of test features, and this plot was creating throwing some error, because for our this model we use three features, that is median income, house age, and population. And it's difficult, we cannot plot the same on a scattered plot, that is a 2D plot. So there are three features, and there is one prediction, that is the y test. So you can understand, like, x is three-dimensional, right? And the plot we are trying to plot, the plot we are trying to generate is a 2D map. 2D, so x needs to be a 1D thing, and also y needs to be a 1D thing. So that's why it was creating it was throwing some kind of error. Okay, and yeah, we also looked into this pipeline module. So what we were doing, we were previously implementing all these things as steps. Pipeline, what we did is that we bunched them together into a single line, and the same thing was done over here as well. This is the model pipeline.fit, and this was also doing the same error. And at the end, we saw the errors for different kind of models: the linear regression, the L2 regression, L1, and at the end, we saw for the elastic net regression. And yeah, so now we will continue from here. Let me just write it down. So first we will look into this rich CV, that basically we'll look into it. What is this rich CV? And after that, we will see what is grid search CV, and after that, a random search CV. Till this far, any questions? Okay, fine. Okay. So yeah, this is the documentation part for the rich CV. So first, the main thing is to import rich CV into this Colab notebook, and we will be doing this. Let me. Okay, this thing is not needed now. Let me close it. So yeah, this is rich CV. Now we will specify some values to this recipe. So what recipe is mainly doing is that it is finding out the best possible alpha value. So as you can see over here, when we were trying to implement the ridge regression and the lasso regression, we were specifying the alpha values as something as 1, alpha is 0.01. And in the elastic net, there are two alphas, but here we have mentioned it in as a ratio. One is alpha and the other one is the L1 ratio. So basically, you take the two hyperparameters ratio and you put it something like this here. So we were specifying this, but we don't know whether this is the accurate one or this is the optimal uh, hyperparameter or the hyperparameter which is providing us the best result. So we will look into it that how can we check this using this rich CV. So yeah, so I will be referring to the notebook which was provided by yes, yes, please.
Sir,
Sir,
in elastic net, we write it alpha 1 L1 ratio. That part.
yes, this one you are saying.
Hi, yes, sir. What did they do here? L1 ratio, ratio between L1 and L2. L1 is point
Can
0.5.
balance between L1 and L. It controls. So we can just look into what is the definition of L1 ratio over here as well. Or maybe specifically we can look into. So since we are already providing, I think L2, I think we provided one of the hyperparameters. This is mostly, I think, L2. Yes. Yes. I will share the collab notebook at the end. So yeah, as you let me open the elastic net this documentation, then it will be clearer to you as regularization. So this is the thing, minimizing the objective alpha into L1 ratio into W1 0.5 into alpha into 1 minus L1 ratio into this thing. So this one, as you can see, is so here what is doing is that alpha, we have specified an alpha value right over here. Here it's alpha is 0.1 value. So the uh, first thing which we are providing, so there are, let me better it will be if I write it down over here. So let me write hyperparameter parameter for L1. So a hyperparameter for L1 will be alpha into L1 ratio. Here, yeah, that's what is written over here in the documentation, as you can see. And so what will be the answer over here? The L1 ratio is 0.05 and alpha is 0.1. So it will be 0.05. And the hyperparameter for L2, hyperpara, sorry, hyperparameter for L2 will be equals to alpha into, sorry, what was written? I think alpha into 1 minus L1 ratio. This will be 1. So this is, I think, in the it is written in the documentation. we can go through it, but actual thing, what is this, what is the specific reason for using this thing, that ratio part, or how does this ratio determines the performance of the elastic net, that I think you have to go through some of this text over here. Okay, maybe I can just open for some part. Elastic net, this is the formula, as you can see. So here they have used something, what is alpha and all, but yeah, but you can check this out. So is this fine till this?
Okay, sir.
Yep. Okay. Yeah, but here we can calculate it down. So alpha equals to, this one is 1, right? What is, sorry, point 0.1, point 0.1, and this is also L1 minus L1 ratio. L1 is, I think, point 0.5, so point 0.5. So this also will be same, 0.05. Right. Okay. Yeah. So here where we, so this is the thing. Again, we have to reinitialize this because we don't want any kind of noise or any kind of caching issue. So maybe we can just reassign this data values again for our own uses. So what we can do is that we can again x comma y, we can just reinitialize the data. Mainly what we are trying to do is that if for by many mistake, if there is any caching issue of the x comma y variable, so we don't want that. So that's why we are cleaning this up. We are reassigning the values over there. So maybe, okay, x comma y h, and yeah, x, we were using the same number of data sets over here as well. Where is that x? Where is that thing? X equals to this plot. Okay. Right. I think this on, yeah, and the test split, training and test split needs to be done. Okay. Yeah. Yeah. Now I think it's reinitialized, and now maybe we can use the pipeline module. Where is that pipeline? Whatever pipeline we were using over here. So we use this pipeline module as it is because uh, we don't want to again perform the polynomial feature this thing and again uh, do the ridge regression part. So there will be more number of lines. So as a whole, we will try to just implement the pipeline part, right? Okay, I will just be referring to some of the codes over here. Sorry about that. Yeah, ridge is ridge. Mm, Great. So it is a great city. Ridge regression, hyperbolic ridge regression. Great city, yes, here. So alpha list here, sir has used something log space. So yeah, we will be looking into this part. So we need only this thing, this part, right? For our code. Nothing more than this. Let me just write it down. Mm, okay, this will be one bracket over here.
Sir, here we work on ridge CV, though we can also take model is equal to linear regression.
The model equals linear
Necessary.
regression we have used.
It is necessary to take it.
Not necessary to use. I'm deleting that. Okay, and this is the alpha list values. Okay, and we were missing something. CV was CV. Let me just take this within as 10, some 10 values. Okay, let's see what happens. Okay, it has performed. So yeah, we can go through the documentation part. So alpha list values means these are the alphas in which it will do the search exactly. So alpha list, if you can just, I can just print it down. So these are the 20 alpha values through which it will perform the search, and it will give me the uh, the parameter which will perform the best in when we are using this cross validation. Here I what I have used is 10. So as you can see over here, let me open this thing. So these are the rich CV, these are the parameters. So here he has here in the documentation they have specified three values, but here we have specified as there in the collab notebook. We have used 20 values. We can also reduce it and whatever values we want, right? And yeah, CV equals to none over here. Generator and iter default equals to none. Here we have used 10 uh, cross validation folds, and yeah, so we have got something. So we will just check this now. So this is they are checking this fit part. Okay, so yeah, let me just complete this. Let me just keep it over here. There is CV results, receive pipeline. So here we have just mentioned it as pipeline. Maybe we can just because in the previous codes also we have used the name same as pipeline. So maybe we can just change it over here. This will be X train, since we are using this X train, and this will be Y train. Okay, let's perform this again, and let's see. Just doing something, and yeah, we got this. uh, okay, let me just print it down. Okay, let's see, so why it's not printing. Okay, okay, this is actually some class kind of thing. Okay, let me just print it down over here. Okay, so yeah, as you can see here, so the score with the best alpha is zero point 0.5 minus 0.577, and the error with the best alpha is the 0.5 0.57. So error with the score with the best alpha is minus 0.577, and error with the best alpha is 0.577. So similar, because error and score, these are like analogous, opposite to each other. So here I have used this negative mean absolute error. So I can justify remove this. What will happen? Okay. Something related to fit. Okay. So negative mean gamma. Okay, these are the negative mean square error. We can use this thing to check mean absolute error we were checking. So let me use the mean square error, and let's see what we get out of this then. Just remember the parameter which we the score with the best alpha is. Okay, let me just print out the alpha here. Then it will be useful for us to differentiate, see if there is any kind of differentiation visible if we change the scoring mechanism. Okay, alpha list, it's CV. Sorry. Okay, so the best value for alpha is 0.0001. Okay, now we were using mean square error, negative mean square error. Okay, okay. It has performed. And let's see what kind of error we will get now. Okay, the alpha is same. It's coming as 0.0001. Similarly, we can, this is -4 to something 0. Here we can also change these values. Suppose we change it to something -10 to something 1, or we can just, let me, for the visualization part, maybe let me just plot this. What did it plot basically? Uh, yeah. What is this? No, it will not come like this. So maybe I just wanted to plot the alpha values. How does it looks like? Alpha list, sorry, alpha list. Yeah. So as you can see, these are the alpha list values, and like this, it is moving like this. Okay. And from here, it is choosing something as some point here, sorry, 0.001 something. Okay. Yeah. So this is the cross validation part, and yeah, we got the cross validation. This thing what we wanted to see is that if we can generate this whatever results which we are obtaining for different alpha values, and if we can just store it down and we can just visualize that also, I think we can do it. So instead of alpha list, so what we can do is that similarly, instead of rich cv, what we can do is that we can implement this model part, and here in the for loop part we can just pass the alpha values, right? So let's try to do that.
Sir, can you please sum up once what we are doing?
uh,
I cannot catch it.
with what?
Complete once more the whole process, sir, from where we started and what we want to do.
This rich cv part you are saying?
Yes, sir. Yes, sir.
Okay.
What we
So
are trying to do and
yes.
once only sum up, sir.
Okay, so what we are trying to do is that previously we saw that we were introducing some penalty terms in the this model, right? Because there is some issue with the noise and all. So because of that, we were introducing some penalty terms, and now for the penalty term, we said that there is a hyperparameter alpha which is tuning the amount of penalty which we are introducing over there, and we don't know what is the exact or the optimal, not the exact, we don't know what is the optimal alpha values that could be useful for our problem. So for that, what we are trying to do is that we are trying to search for the alpha values that will provide us a somehow optimal uh, value, optimal error, or optimal score, you can say. So for this problem, first we were using this rich cv. Here what we have done is that instead of in rich cv, this is the ridge regression part, normal ridge regression part, and we have passed some of the alpha values, and it is performing some cross validation, and for the different alpha values it is providing us the alpha value for which the cross validation result is the best. And based on this operation, it is saying that this hyperparameter is best for your data set and for your problem. Based
Sir, the pipeline you have made in the off code
Hmm.
at 62,
Hmm.
where we are reaching this pipeline,
Where the
pipeline, where this pipeline is being used.
pipeline, here we have used, right?
Okay, got it.
I think this part you missed. Like now we wanted to see like how this alpha list looks like. So that's why I plotted this part. So here we are saying that we are fitting this pipeline over here, X train and Y train. Got it? Or maybe we can just use this X and Y. Let's see. Now it will take some time, and then, yeah. The best value for alpha is 10. Now it changed suddenly. Okay. So based on the data set you have, it also is dependent upon the data set and how does the data looks like. Okay.
Sir, but we only need to fit it on training part of the data, right?
What? Sorry, can you repeat?
We need to fit this pipeline to the training part of data now,
Yes.
the whole X and Y, right?
Mm-hmm.
So
You want
last part, yes,
you want
yes.
you wanted to see the prediction part.
No, sir. I wanted to understand what is you change this X to Y,
Mhm.
uh, X trend and Y trend to X and Y. Then what is the use of this? Do we need to fit this with X and Y or only with X trend and Y trend?
No, no. Here I just use this extend and whiten just to showcase. But normally, what does cross validation does? Cross validation shuffles this data set right into different kind of what they call this folds, right? So for finding out the optimal alpha values, we can use this
Yes,
X.
yes, yes.
Yes,
Where one set of data is already kept aside for the validation. That's
yes, yes. So we can use this X and
we can use.
X
Okay.
comma Y. But of course, now if you suppose your problem is something else, now you want to suppose you don't know the test data at all. Here we know the test data, right? Now you don't know the test data. So that in that case, whatever data you have, you can train it using that. You get the alpha values, and then you just do a normal model fitting over here with the data and use that model to predict the y test. Is it fine?
Okay. Okay, sir. Thank you.
Yes. Yeah, so this is the rich CV part. So as you can see, so here this is ill condition matrix, linear algebra warning ill condition matrix, because maybe because the number of rows are not enough. So because of that, there can be some issue. Okay. Now the next part is this grid search CV. Grid search, and then we will proceed with the random search. So I just take whatever the code sir has provided. Lasso regression. Yeah, so similarly we can do this for read grid search CV. And yeah, let me just open the grid search CV documentation as well. Grid search CV SQL learn. Okay. This is what is 1.6.1. What we were using here, it was 1.2.2. Okay. Fine. Okay. Yeah, this is the grid search CV part. And yeah, let's first import this thing. Grid search CV. Okay. Grid search CV. Sorry about that. Let's create another pipeline. Right. This is rich regulation pipeline. We will name something as something different here. We will name as pipeline grids. Pipeline, maybe we can keep it like this. Rich grid CV pipeline. Pipeline equals to something like this. And here, okay, grid CV is done, so we can close it down. and this is the values. Let me just see this thing. Poly grid pipeline reach. This is it's a CV. So pipeline number of jobs. Negative incident. So I can just copy. This is the thing rich. Here he has used rich and parameter grid. This is the parameter grid. And okay, fine. Okay. So this is the rich CV part. We don't need now this thing. We just need the rich CV, I think. And this is the thing we need. And this is just we can name as rich. Okay. And grid pipeline, rich grid pipeline. We have not mentioned it over here. Okay. This name will be rich grid. Okay. But this is the polynomial degree. Here he has used something polynomial, I think. Okay. He has used this polynomial part. Okay. And here we will just similarly we will change it to something extreme and extreme and so we are fitting it to extreme, and this will be shops. And here also he has used cross validation again, so we will stick to it 10. So then okay, first let's go with the X train and Y train part, then we can go through it. Okay, what happened? Why is this error? We didn't fit. Okay. Alpha is valid alpha per target. Okay, what is the issue? Degrees equals to 2 we have passed, so alpha saying something as some parameter mismatch is there. Invalid parameter alpha for estimated evalids are alpha per target, alpha CVP. This is throwing error in which line? Grid search x comma y. Here it is showing, and grid search, but this is the thing, and village grid parameter grid, this is thing. Okay, number of jobs equals to 2. Okay, and ridge is ridge CV. We just copy I just copy pasted it, but anyway, maybe okay, I think it has fitted this model grid search. So here you can see we are passing this polynomial degrees 1 comma 2 comma 3. These are the 3 degrees we have passed, and same the ridge alpha values we are passing the previous alpha values minus 420 nums equals to 20, and ridge grid search dot fit, and we can just what is done here. So we can just print the CV dot results. We need this mean train error, and yeah, print this CV mean train error. So this is the mean Just a second. Mean train error and best mean absolute error for polynomial regression is this thing. So let me just. It is showing something as the mean absolute. So here did we mention the negative? Okay, mean absolute error we have mentioned this. So this is showing this mean absolute error of the polynomial on the train set is 0.578, and this is the variance part, and this mean trace error, and this is the what they call this this is the standard deviation. And what we can also see is the parameters which gave us the best scores. So best parameters we can print it out, right? So yeah, so remember we are using this, okay, the polynomial degree. So the polynomial degree 3 and the ridge alpha value 1 gave us the best mean absolute error. Now we can also change this polynomial degree to something. Okay, maybe we can, one means it's just a linear regression. So we can increase it to something 4, 5, 6, and then we can check it. Okay, it has performed the grid search CV. Now, okay, the error has not changed much. But now, as you can see, the polynomial degree has changed something as 5, and the ridge alpha values has changed into something 0.37. So yeah, like this, you can also like specify the polynomial degrees over here, and let it do the uh, search for you. Okay, and yeah, this is the thing. Also, what we can do is that this is the thing, and yeah, the remaining part is random search CV. That's the thing which is left. And I think we can also do the same thing for lasso regression. This is pretty much, it will be same. Sorry about that. Yeah, that's similar, things are similar, quite similar. Instead of rich CV, you have to here you have to just specify lasso instead of rich CV. So things are quite similar as for the lasso and for the rich part, right? Now we will see what is this regulation, and we'll go to the random search CV part. Okay, random search CV. Skill learn. So randomized search CV. This is the old documentation, I think. Okay. This is not. Okay. Yeah, it has opened down. So maybe we will use the same pipeline over here. We need rename it as randomized pipeline. Yeah, let's run now, and yeah, so distribution equals to this thing. Then import something as uniform. Okay. So here they are using a uniform distribution. Okay. Distribution equals to this thing, and we don't need this thing called L1 and L2 penalty since we are looking into ridge part. So yeah, this thing is done. And now maybe we just have to fit this part. Here instead of this, we will pass this one. So yeah, same thing. We will, instead of logistic, we will pass ridge pipeline. Okay, it has performed, and now we will just check. Okay, this is search, and then we will go to the best parameters. What happened? Valid parameters are feature scaling, our memory steps. Okay, so it failed over here. Anyway, let's see what we can do here. Why is this error is coming? Valid parameters are okay. C equals to uniform solver. Why is it saying valid parameters are memory and all? Is it because I'm using this thing, ridge part? Okay. Let's Then maybe we can just stick to this only. Okay. Penalty equals. Don't know whether this thing will work or not. It won't work. Anyone has any idea why is it not working? Okay. Scoring is not fast. Scoring is not fast. Sorry, that's the issue. Eh, yeah. Anyone wants to say something? Only valid parameters are memory, transform minutes, and all. Okay. Randomized set CD scale on. Okay, I think there is some small mistake which I am not uh, able to find out now. Okay, but anyway, if you just try to similarly, if you try to fit this model over here and pass this uniform distribution, it will search through this uniform distribution and then try to figure out to which parameters provide you the best outcome. So yeah, that's the thing. I will fix this code and then upload this to the Google Calendar events part. So yeah, this was the remaining part, which was hyperparameter tuning. And yeah, till this far, any question? Or if anyone wants to see anything else? Anyone? Any questions, anyone? Anyway, so many less students have attended today. Any reason for that? Okay, again, complete silence. Okay. Anyway, then yeah, I will fix this code and then upload it to the calendar events. So as you know, you can just go to the yeah, calendar part like this, and from there, if you just click this, okay, let me just open my own calendar. So this is the thing, right? Yeah. So if you open it up, so here in the events part, I will how to open this thing. So in the events part, I will give the share this Google Colab notebook link over here. From there, you can just open it out and try different kinds of try this notebook to figure out, try different types of regular tuning, hyperparameter tuning, and also to play with the polynomial features and all. Okay. Yeah. Then that's all for today, and we will be meeting next week. So I think there is a revision session on 20th, right? So please attend, and if you have any doubts also, please try to get it cleared during the revision session. Okay. Any question till this far then?
No, sir.
Okay. Okay, then thank you. Thanks for joining. See you on 20th. Okay.
Thank you, sir.
Thank you, sir.
Will we also cover week 6 before quiz 1? I think, yeah, after the revision session, we have some live sessions over there. I think they will, it will be covered, but it will be covered by other instructors. So, yeah. Okay. Okay. Thanks for joining. Thank you. Ravikant, you have any question? Ravikant? Okay. Thanks for joining. Thank you.